Okay guys, so Assalamualaikum warahmatullahi wabarakatuh and a very good morning to all of you. So my name is Mohd Nadarul Aiman bin Zulkefly and we are from group 14. So the reason of this presentation is to fulfill our LO, to fill our learning outcomes, which there we have 4 of the learning outcomes. So as you can see here, there is the list of my group mates. We have 5 members, 5 group members. Okay, so let's jump to the introduction first because that is my part. Okay, so before we jump to our LOs, we should know something about the mechanics of material. So basically, the mechanics of material is a branch of mechanics that develop relationship between the external loads applied to a deformable body and the intensity of internal forces acting within the body as well as the deformation of the body. So some concept of engineering mechanics in material also include stress and strain, like we learned, force system on structure, moment of inertia, and shear and bending moment in a beam. So basically these things we already learned in our previous semester or in this semester. Okay, now let's go to our learning outcomes. So basically we have 4 learning outcomes. So first of all, for learning outcome 1, we should be able to solve problems involving a body under an action of axial and torsional load. Okay, so for the next learning outcomes, which is learning outcome 2, LO2, we should be able to solve problem involving stress in beams. Okay, and for the third one is we are able to evaluate stress and deformation of biomedical device due to compound load. And lastly, LO4, we are able to present ideas on selected topics on materials in mechanics of materials applied in the biomedical engineering field, whether in a presentation form or in oral form or like in report or in written form. Okay, so for our body we have chose crutches. Okay, so crutches is a type of walking aid that serves to increase the size of individual's base of support. So basically the crutches help to transfer the body weight from the upper body, since the patient cannot use their leg, whether because of their leg is broken or they already lost their leg due to amputation. Okay, and then we have 3 types of crutches. We have axillary crutches, elbow crutches, and gutter crutches. Okay, so the common crutches that used by the patient is axillary crutches, like we can see in these pictures. So basically the use of crutches is for the patient that already lost their limb or they are having problems with balance or impaired strength.
Doctor. Assalamualaikum and very good day to Doctor. My name is Irlyani Nawwarah binti Muhammad Samsir, KIB2003. So in this group assignment video, I'll explain about the first learning outcome, which is to solve involving a body under the action of torsional load. Okay, since we have learned in our syllabus, torsion is the twisting of an object caused by a moment acting about the object's longitudinal axis. Therefore, on this assistive device, we believe the patient who used these crutches, there would be a twisting on the hand grip part. Therefore, we only focuses to calculate the torsional load that acting upon this part only. So, for my part, the objectives that I want to achieve are to find the shear strain on the circular bar, the hand grip, because we know that the torsion generates stresses and strains. The second one is to determine the torque that causes maximum shearing stress of 45 megapascal. And lastly, we want to find the shear modulus, the G. Okay, in order to find this objective, we have to make some assumptions. First, we assume that the hand grip as a solid cylindrical bar and the angle of twist is assumed to be 15 degrees. And we decided to put the shearing stress to be not exceeding 45 megapascal. Okay, these are the informations we have gathered about the hand grip part of these crutches. Okay, first is the angle of twist is 15 degrees. The length of the hand grip here is 10 cm and the diameter of the bar, the diameter is 5 cm, making the radius to be 2.5 cm. and the maximum shearing stress is 45 megapascal. Okay, first objective, we want to find the shear strength. Here is the formula. We just need to insert the values from the information, and we got the shear strength to be 3.75. Second one is to determine the torque that causes a maximum shearing stress of 45 megapascals. Okay, first of all, we have to rearrange the shear stress formula to make sure the T sits alone on the left, and then we have to find the polar moment of inertia, J. Just have to put it in the formula here. Pi over 2 times r to the power of 4. R is 2.5 centimeter, so 2.5 times 10 to the power of negative 2 in meter. We got J is 61.36 times 10 to the power of negative 6 meter to the power of 4. After we have found the J, we can insert the value into this equation to find the torque value, which is to be 110.45 kilonewton meter. Last but not least, we want to find the shear modulus of this part. First of all, we have to rearrange the angle of twist formula to make sure the G sits alone on the left. After that, we just need to insert the values into the equation like this, and the final value of G we have is 11.99 megapascal. I think that's all from my part.
Hi and Assalamualaikum everyone. My name is Ameeza Haneem Binti Shamsul Anuar, KIB2003. I will continue with learning outcome 2, solve problem involving stress in Binti. So, this is the part that we will be focusing on, and we will need to find the shear force V, maximum bending moment max, and also maximum bending stress sigma max of the padded forearm support. So, this is some assumption that we have made. First, the force applied by patient is uniformly distributed, which is 540 Newton per meter, as you can see here. Second, length, width, and height for the padded forearm support are 20 cm, 6.5 cm, and 5 cm respectively. And lastly, the summation of horizontal forces is 0, which is summation of Fx is equal to 0. So how to find the shear force V? First, we need to draw the free body diagram as I have drawn here. Next, we use the formula V equal to negative omega times length, which is omega is force, and length is 20 cm. And we simply substitute the value of force and length, which is the force is 540 Newton per meter, while length is 0.2 meter. And we got V equal to negative 108 Newton. So the shear force for this part is 108 Newton. For the maximum bending moment, Faiz will continue. Thank you.
Assalamualaikum. My name is Muhammad Faiz bin Huzamri, matric number KIB2003. So for my part, I'm going to explain to you how you're going to find the maximum bending moment and the maximum shearing stress of our padded forearm. So right here we have the free body diagram. And using the formula of maximum bending moment equal to negative force times length squared divided by 2, we will be able to find the component we are searching for, which is the bending moment. So next, we simply substitute all the equation with the info, with the number that we have gathered. Whereby for our force, we have 550 Newton per meter. For the length, since it's 20 centimeter from one end to the other end, we're going to change the value from centimeter into the meter. Hence, we got the value 0.2 meters squared, and then divide them by 2, and we get the answer negative 10.8 Newton meter. So next,
Maximum bending stress. But however, to find the maximum bending stress, we must know the moment of the inertia first. So for our moment of inertia, we are going to choose the side of the padded forearm, whereby C is the center, the height from this point to the middle point, and H indicates the height of this thing from this point to this point, and our base is located here from this point to this point. Alright,
So let's look at the formula. So formula for this kind of shape, this kind of area, we're going to use b h cube divided by 12. So next we substitute our number into the equation. So for our base, the length is 0.065, whereby for our height it's 0.05, and divide them by 12, we get the answer 6.77 power negative 7 power negative 10. And only after that we will be able to find our maximum bending stress, because now we have the I component. Now we can settle our problem or our equation. So we're going to use this formula. Maximum bending stress is equal to the maximum bending moment times with c. C is the value for this thing, from the height from this point to the middle point, and divide them by the moment of the inertia of this whole thing. And then we substitute them into the equations. So the moment going to be 10.8 Newton meter. The value of the c is 0.025. Since the height is 0.05, we divide them by 2, we get the answer 0.02, and then we divide them by the moment of inertia, which is 6.7 times 10 to the power negative 7, and hence we get our answer, which is 398.818 kilopascal. And that's all from me. Thank you.
Hello, my name is Ramzan Sayani, KIB2003, and my part is to present regarding the learning outcome tree, which concerning the evolution of stress and deformation of biomedical devices due to compound load. So as you can see on the screen, this is the device that has been chosen by our group, which is the auxiliary crutch. And the black figures is actually the free body diagram of the device. So the part that has been circled is the part where I'm going to focus on regarding the analysis of the stress and deformation. So these are the parameters involved, which is the diameter of 5 cm, the length of 36 cm, and load applied is 540 Newton, and a ground reaction force of 570 Newton. So the first part in computing stress, first of all we need to compute the area of metal rod by using the equation of pi d squared over 4, which we obtain a value of 1.963 times 10 power of negative 3 meters squared. The next part is computing the total force involved in this system. So since the ground reaction force and the load applied is both in opposite direction, we assume that the force going upward is in the positive direction and going downward is in the negative direction. Hence, the total force is 30 Newton. So by using the formula of stress equal to POE, we can compute that the total stress at the part is 15.28 kilopascal. The next part is we're going to compute the deformation of the actual parts. So by using the formula of deformation equal to PL over AE, whereas the P is force, L is length, A is area, and E is the Young's modulus or modulus of elasticity, we assume that the material used is aluminium, which is the most common material used in crutches. So as we know that the standard modulus of elasticity for aluminium is 69 gigapascal. That is the value that we're going to plug in when we are computing the deformation. So once we have plugged all of the value that we already obtained, we're going to get the value for the deformation, which is that value is 79.736 nanometer. So that's all for my part. Thank you.
Okay guys, so it's me again, Nadarul Aiman. So conclude that crutches is very important to all of us, and we can study the stress, the torsional load, the axial loading, the stress and the deformation of the beams in the crutches. So I would like to emphasize here that our group managed to cover all of our learning outcomes, and crutches is a very good example of medical device that use all the principle of torsional load, axial load, stress and deformation, and also for the person that use crutches, don't be embarrassed, because the device that you use really helping us in making this video. So that's the end of our video. So I hope you guys enjoy it and gain some knowledge. That's all for me, and that's all for our group. Goodbye.